Hello and welcome to the last week for this particular course on Introduction to Economic Growth. So, I hope you have liked the lectures thus far, and before we proceed with this week's lecture, let us do a quick recap from week 3, that is last week. So, we had first began by giving an introduction to what is economic growth and what is the motivation behind studying economic growth. And we did see, some pictorial evidence, graphs, etc., the stylized facts, etc. That is what we had seen in the first week. And then in the second week, we had talked more about the data, because what we actually come across in real life is mostly, readings or articles based on the data. So, understanding this data is essential. We also talked about that what if GDP data is not available for some reason or the other. Okay, maybe as researchers, we encounter such situations very often, even as a general reader, and that is why we did take a look at that newspaper article on night lights in the Indian context. Sometimes if we would like to learn a little bit more about, maybe places that are at a more granular level, their GDP data is not available, then we can use proxy variables. So, in all those contexts, we had talked about the data. After talking about data, we talked about a framework for analysis, because it is one thing that yes, we do have the data and we can analyze the data and we can come to certain conclusions, but as policy makers especially, it helps if we have a model that is very handy to us, an economic model, right. So, for a framework of analysis, as we had mentioned, there are various kinds of growth models. Okay. There is no one single growth model that makes our job very difficult, so as to say. But as students, we have a starting point typically, and that is the Solow growth model. The Solow growth model is due to Robert Solow. We had discussed that model at great length. That model is also known as the neoclassical growth model. Sometimes it is also known as an exogenous growth model. Why? Because all the important parameters that we saw in the model, that leads to a change in the steady state. Remember, small s, small n, small g, all these were exogenous to the model. So, that is why it is also sometimes known as an exogenous growth model. We had also discussed that how technological progress or rate of change in technology is a very, very crucial factor in ensuring growth, especially growth at the steady state. So, for countries that have reached the steady state, for them, if they have to keep on growing perpetually, then what is their source of growth? And that source of growth is technological progress. That was the conclusion from the augmented Solow growth model. In while discussing the Solow growth model, we also said that all these various policy implications come out from there. For instance, what happens in an economy if saving rate increases? What happens in an economy if there is population slowdown? And what happens in an economy when productivity growth occurs? So, we can think of these as policy questions, and those were also answered within the Solow framework. So, all these are the things that we had covered so far. Today, almost in continuation, because convergence is a topic that is like an offshoot of the Solow growth model. Okay, so, once we are more familiar and we get more comfortable with the Solow growth model, now we can talk about questions like, does the Solow growth model tell us anything about this question that many a times we ask ourselves this question, that would the poor countries ever catch up with the rich economies? Okay, this is known as the catching up, right? Because if we can recall one of the facts that we had seen under stylized facts of economic growth, that nothing is forever, in the sense that it is not like poorer economies will remain poor forever and vice versa. So, is there a process by which poorer economies will catch up with the more affluent economies? Is there something that the solo growth model, talks about? So, convergence, as the term suggests, the way we understand the term convergence, in just the regular English language, is something that converges. So, here in the same context, we are going to talk about whether the poorer economies are going to converge to the economic status of the richer economies. Okay. So, up to that, I think, at this level, this is the definition of convergence we will use. Gradually, we will get introduced to more technical, definitions of convergence. But I suppose the question, the driving question behind convergence is, are the poor economies ever going to catch up with the richer economies? Okay. And since technological progress or productivity growth, now this was also mentioned earlier, as economists we use both these words interchangeably, they are very important. So, naturally now comes the question, can we actually measure technological progress? Okay. We talk of technology all the time, but technology is intangible in nature. So, how is it that we can measure the growth in technology? So, to answer that question, we will get into this framework of growth accounting. So, that comes within the broad area of productivity, that is why productivity is mentioned here. And similar to growth accounting, but not the same thing, by the way, is something known as development accounting, okay, which will tell us that what percentage of, or when we are especially comparing across economies, that how much of importance should be given to productivity growth versus how much of importance should be given to growth in factors. Factors means labor, capital, etc. So, since these are two kind of related concepts, but not the same things, but they are related to productivity. So, we have clubbed them under this broad head of productivity. And the final thing that we will be talking about this week is we will provide a background for the emergence of what is known as new growth models, okay, sometimes also known as endogenous growth models. I have not written it here, but sometimes you might hear the term that endogenous growth models. I think the distinction is clear, because as we had said, for the solo growth model, the most important parameters, okay, they were all exogenous to the model. That is one of the limitations of the model. So, now suppose if someone asks the question that, okay, we understand that technological progress is very important for growth going by solo, but tell me, where does this technological progress come from? What should I do to ensure technological progress? Now, that is not answered within the solo framework. Why? We will recall that small g, okay, its value was exogenous. G was not a function of anything. So, we really do not know, going by the solo growth model, that what is the source of that technological progress. Okay? And this is exactly what endogenous growth theory, or the new growth models as we call them, they address. So, they now go one step further and they look more into how this technological progress comes about, how can that be ensured, and what kind of environment do economies require to ensure that there is productivity growth. Okay? So, we will not be talking about any specific model which comes under the new growth models here, but we will kind of give an outline of the most important contributors to this particular theory. And with that, we will be wrapping up this particular course. So, with that, let us begin with the first question. So, we have to again get into that solo mode once again. This is almost like a continuation of the solo growth model, and we are asking ourselves, is there convergence? That is why we see a question mark right next to it. Now, why is there a question mark? Because the solo growth model, it makes a very strong prediction. What is that strong prediction? Suppose countries in the long run, They do not display differences in rates of technological progress, savings rate, population growth rate, and capital depreciation. Then in that case, in all countries, the capital per unit of effective labor, they are going to converge to a common value irrespective of their initial capital stock. Now, does that hold, yes or no? So, to understand this, and there are two concepts of convergence. Okay, one is unconditional convergence and one is conditional convergence. Let us look at it, and I would also urge you that while I am drawing the figures here, please try and draw this as well, because not only is it a good practice, but you know, every time we draw these figures, I think at least for me, the concepts become very clear. So, let us begin. Let us ask the question slightly differently here, because we are talking of convergence. So, convergence of what? So, let us say, suppose we are asking ourselves the question that do poor economies ever catch up with the affluent economies? Okay. To understand this, let us try and see whether we have an answer to this question based on what we have covered in solo thus far. Okay. Now, possibly I am not going to label everything here. I am assuming that we are already familiar with this particular figure. So, I will just draw those things that are required for us. Okay. Please label every diagram. Okay. I am just trying to demonstrate how we might arrive at an answer to this question that we have asked ourselves here, right. So, we have the basic diagram in front of us. Let us say that this is the initial K for country A, let us say in the year 1960. Okay. This is a relatively poorer economy, because there is also another country B. And how do we know B is a more affluent economy? It is indicated by its position here. Okay, this KB is greater than KA. Okay. Now, from the solo growth model, what do we know? We already know the answer, right? So, what do we know from the dynamics of the solo growth model? We know what is going to happen to this country KA, which is originally it is here, KB is here, that is country B is here in terms of K. What is going to happen to both these countries over a period of time? Okay. Over a period of time, KA is going to move from here, and this movement will continue until it reaches the point K star. We have gone over this entire dynamics before while talking about the solo growth model. So, if you are still not familiar with this, I would urge you, please go back to that lectures and see how this country A is going to move from its position, which is currently at KA 1960 to K star SS. What is K star SS? This is a steady state. Okay. Okay. What is going to happen to country B? Country B is also going to move from its initial position here and is going to reach K star SS. Okay. So, both countries then over a period of time, we are not getting into the rate of convergence and how long it will take for the different countries to reach there. All those things can be calculated, and if you are interested, you should actually look up, right. But the broad takeaway from here is, no matter where countries start from, they are eventually going to converge to this K star SS, right. Now, are there some very strong assumptions that we are making, or is there something with which we have to qualify then the answer to this question? So then if we go by this particular figure and we have asked ourselves this particular question, what is the answer to this question? Yes, then the poorer economies are eventually going to catch up with the more affluent economies. Is that the answer? Well, partially, because there are some very strong assumptions that have been made here, and I hope we could realize that while we were drawing this figure here. So now let us point out what are those strong assumptions that we have made here. Now, the very fact that we had country A and country B in the same figure, okay, what does that imply? It pretty much implies, remember where did we get all these curves and lines from? Okay. We had all these variables, parameters, etc. Now, if we have only one of S of Fk curve and one of that n plus g plus delta curve, and if we have placed both countries on the x-axis, then implicitly we have made the assumption that both countries have the same production function, they have same values of S, N, G, delta, etc. Okay. So, yes, we have then made a very strong assumption here, and if we ask ourselves the question that, well, is this really the case when we look around us, especially when we are comparing poor economies and rich economies? The answer is no, right? So, then this answer is yes, provided there are many strong assumptions that have been made here. And what are those strong assumptions? The assumptions are the values of small n, delta, g, s, they are all the same. Okay, production function is also the same. Those are the strong assumptions that have been made. So, that is why we said that this answer is partial, because, well, if this is the case, then as per the Solow prediction, they are going to converge where? They are going to converge here, and they are going to converge in terms of their per capita income, right? But then now, before we proceed, so this is something known as unconditional convergence. Why is this known as unconditional convergence? This is known as unconditional convergence because no matter where an economy begins from, that is, you can also have some other economy here, we can have some other economy here, okay. No matter where an economy begins from, if these assumptions hold, then they are all going to converge to the same steady state. So, it is unconditional. Why? Because it is not conditional on the starting point. So, country A can have a lower starting point compared to country D, which has a much higher starting point because it is relatively closer to the steady state, but the starting point does not matter. Okay. It can only matter in terms of timing, but that is not what we are talking about here. Because when we say convergence, look at the question was, are poor economies ever going to catch up with rich economies? So, this is the notion of unconditional convergence, because to draw this itself, now I have 4 countries, all 4 countries have been drawn using the same figure, and that itself implies that we have made very strong assumptions here that for all the 4 countries, they all have the same parameters. Otherwise, we could not have drawn, all of them here using the same figure here, right. So, this is what is known as unconditional convergence. So, unconditional convergence, then what does it tell us? It tells us that as long as we have these strong assumptions that we just mentioned, all countries are going to converge to a common, same, or we can call it a common steady state value. Okay, so this is what unconditional convergence tells us. Now, if you are wondering that, well, these assumptions, they are very strong, and in real life, does it hold? Okay, possibly no. We have some odd 200 countries around the world, and if we are asking ourselves this question, and if we make this assumption, I mean, theoretically we can make this assumption, but when we go back to the data, as we said, in real life, high chances it doesn't hold. But again, there are some exceptions. If the countries, or if a group of countries are somewhat similar in nature, right? So we can think of maybe the SAARC countries, right? SAARC, or the EU countries, right, where they are more or less similar in nature. So N value, S value, they will not be exactly equal to each other, but they are fairly similar to each other, maybe in those cases. So for, one can call them like groups of countries with similar features. Then for them, this assumption is not so implausible. Okay. So as we said, if we are then looking at the SAARC countries, or if we are looking at the EU countries, and then we are asking ourselves this question, I think then this stands. Okay. Then we are good to go with unconditional convergence. And what we would say is, irrespective of whether each of these countries, that is the SAARC nations as we call them, where they start from, irrespective of their starting point, they are all going to converge to a common steady state level. Okay. So naturally, whenever such predictions are made based on theory, we would like to test it with data. And this part that I am talking about here, this example and the following graphs, they are all taken from Debrajre's Development Economics. So there was a study that tried to test this. So one can test for unconditional convergence, and this is unconditional convergence that we talked about here. And how are we going to test for unconditional convergence? Here we could draw a figure and everything. With data, how we can test for unconditional convergence is we look at whether there is a strong negative relationship between growth rate of per capita income and the initial value of per capita income. Why is that the case? Because as we know from the solo growth model, further away one is from the steady state, the growth rate is going to be higher. Closer it gets, it is going to slow down. So there has to be an inverse relation between the starting point and the subsequent growth rates. Okay. So this study, what it considered, so now we are looking for, as we can see from the title here, so unconditional convergence evidence or lack of unconditional convergence, question mark, because that is what we will see. So in this study, these countries were considered and they have been ranked from poorest to richest: Japan, Finland, Sweden, till Belgium, UK and Australia. And this is the time period that was considered. So the initial time period that was considered was 1870. So log of per capita income has been plotted on the x-axis. What is plotted on the y-axis? As we said, that the growth rate over a period of time. So here this is almost close to a century. This long a time has been considered. Okay. And what is found for all these 16 studies, this study was conducted by Madison, right? And as I mentioned earlier, this figure has been taken from Development Economics book by Debrajre. Okay. So what do we see here? So this is a scatter plot, but if we were to fit a line here, it's a negatively sloped line, right? So what does this indicate and what are we looking for? If we are looking for whether there is evidence of unconditional convergence, yes or no, this line should be negative, right? Is this what we find here? Yes, this is what we find here. So, is there evidence of unconditional convergence based on this particular, set of countries that was taken? And they have been ranked as poorest to richest based on 1870. Okay, so this is how they were ranked. The answer is yes. Okay, right? But now comes the next question, and this is what we keep on, doing in research, is we try and see whether everything was covered for, or is there some error that has been made. So, there is a major statistical pitfall in this particular study that was done. Now, this was Baumol's study. This was based on this data that was done. We mentioned earlier that these are the countries that were considered. Now, what was pointed out by Brad DeLong, who did an extension of this work, is he said that the author had considered the countries that were rich ex post, that is, countries that had similar per capita GDP levels in 1979. 1979 is the terminal year of this study. Now, it also strikes us, and when we look at this set of countries here, these are all actually very rich nations in the current period. Okay, they were not all equally rich in 1870, but they are all rich now, and they were possibly all rich during the time of 1979 when this study was conducted. So, the argument that Brad DeLong is giving here is, in 1870, with no knowledge of the future, what criteria would tell us to choose these countries ex ante to test for convergence down the road? Ex ante means before, ex post means before. So, in other words, he is asking that, well, in 1870, we had no clue that these countries are all going to be developed countries 100 years down the line, right? They were all more or less similar in terms of their affluence only 100 years down the line, right? So, he is asking the question that on what basis these particular countries were chosen. So, that is why he is asking, well, if Japan has been chosen, then why not choose Argentina? Okay. And this is what is termed as, in econometrics, something known as a selection bias, because hindsight is no substitute for forecast. Okay. So, this is like saying that countries that were, they were in different states earlier, but currently they have all converged, because remember, by the time the study was being conducted in 1979, all these countries, they are pretty much similar types of countries already, right? So, you are already looking at cases where they have already converged, because in 1870, we did not know what would happen to these countries 100 years down the line. So, ideally, what should be done, or for a true test of convergence, as it should look like, it should have a set of countries that ex ante, that is beforehand itself, they seemed likely to converge to high per capita GDP levels that came to characterize the richest nations decades later. So, what Brad DeLong did was that he addressed this question by adding countries like Argentina, Chile, East Germany, Ireland, New Zealand, Portugal, Spain, all these countries were now included in this set. Okay. He dropped Japan from this particular set, and this is the interesting question, what do we find after all these countries were now included? What do we find? What is the conclusion? What do you see? At least one thing I can clearly see from here, that neat negatively sloped line that was there earlier, remember? And what were the earlier countries? These black ones were the earlier countries. These are the new countries. Okay. Now, if we consider the entire set of these new countries and the countries considered earlier, then looking at the overall plot, at least I do not see a clear, negatively sloped line here, right? This was the finding of Brad DeLong. Okay. So, in fact, that is what has been found true for unconditional convergence. Here we were talking of unconditional convergence. So, if we consider all kinds of countries together, because this is what they were, in 1870, and we did not know 100 years down the line whether they will converge or not. So, if we consider all kinds of countries at the same time, then we do not find much evidence for unconditional convergence, right. So, something that we saw theoretically was coming out from the solo growth model, but here it is not turning out to be the same.